Hello geometry. So this one is going to go really quickly because it's just a quick 6-slide PowerPoint on tangent lines, just looking at a couple definitions. So the standard we're looking at on this one is identifies and describes the radius of a circle that's perpendicular to the tangent line where the radius intersects the circle. Essentially what that just says is that you use the theorems that were given in this unit to solve problems. Next, when we're looking at this, again, this doesn't necessarily need to be in your notes if you know it already. The first thing we need to talk about is a tangent. A tangent to a circle is a line that intersects that circle at exactly one point. That point is called the point of tangency. In this example, we can see that ray AB is a tangent ray, and point A is the point of tangency. Remember, OA is a radius to the circle. The theorem that we also used in the worked out problems, which you need to make sure that you have written down, you can either write it on a tiny card or you can write it in your notebook. It just depends on what works for you. The theorem full on says, if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So essentially, the longer version of it is if line AC is a tangent to circle O at point B, then line AC is perpendicular to OB. And we know, based on our definition of perpendicular, that that means this forms a right angle. I want to point out that this long handwritten way and this long handwritten way, the same thing I wrote right there. So nice, short, sweet, to the point. At the same time, we need to remember that the converse of this is true. So the opposite, if you will. If the plane of a circle, or excuse me, if a line in the plane of the circle is perpendicular to the radius, then that line is a tangent. So either direction, if it's a tangent, we know that it's perpendicular, or if it's perpendicular, we know that it's a tangent. Okay. The next one, this one's probably my favorite out of the two, talks about two congruent tangents. So if we have two tangents to a circle that meet or intersect in one point in space, the segments that are created there must be congruent. So as long as AB and AC are both tangent to the circle A, then the length of AB must equal the length of AC. Again, you can see here the nice longhand version of it, or in your note card, you can put the shorthand version there. So the last one you'll notice in the worked out problems that are on the other video, there's lots of use for the tangent principle when you're circumscribing polygons around circles and using inscribed circles inside of polygons. So I left you guys today with an adorable picture of an inscribed dog. Remember, he's tangent to all the cushions.